Okay, this video is intended as just an introduction to the basic terminology of probability. So hopefully we'll keep it pretty short and concise here. So first, the few things here you might want to jot down. Probability of an event occurring is always between 0 and 1. Okay, if it's a probability of 0, it's never going to happen, cannot happen, and will not happen. If it's a probability of 1, there's a 100% chance that it's going to happen. It will happen. And then there's obviously everything in between. 0.5 is 50%. That means half the time it's going to happen, half the time it won't. Okay, an experiment is a process that generates observable outcomes. Okay, so an experiment is something that you do that makes things happen. So if you roll a die, that's a great example of an experiment. If you draw a card from a deck of cards, those are experiments. An event is one of the outcome, or it could be a set of outcomes. So if we're talking about drawing cards, it could be drawing the Jack of Spades. But it could also be a set of outcomes. For instance, it could be drawing a spade and a jack. All right, so it could be a couple of outcomes that make an event, or drawing a club and then a heart. That might be an event. And that would be a combination of outcomes. And the sample space is all the possible outcomes of the experiment. Okay, so everything that could possibly happen in the experiment, all the outcomes, would be the sample space. We'll do some examples of that in just a second. Okay, so but the most important thing for probability is this. It is that if you want to find the probability of an event, you take the number of events happening, the number of ways an event can happen, number of ways, well actually, number of, let's write this, favorable outcomes, and divide that by the total number of outcomes. Okay, and so that's what it is. So the number of things that you want divided by the total number of things is the way I think about it. If you want to figure out the probability of rolling a 2 or a 6 on a die, there's two ways you can, there's one way to roll a 2, one way to roll a 6. That's 2 possible favorable outcomes divided by how many possibilities? 6, so 2 over 6. So the probability is a third, and this works for probability. This is one of the most fundamental things of probability. It's the number of favorable outcomes divided by the total number of outcomes. All right, let's talk about finding some sample spaces now. So the sample space of tossing a coin. Okay, well the sample space if you're tossing a coin is simply just heads and tails. Heads and tails. All right, that's it. That's the possible outcomes. You flip it, you get a heads. Flip it, you get a tails. Rolling a number cube, that's a die. Okay, rolling a die. Your possibilities are 1, 2, 3, 4, 5, 6. That's the sample space. That's all the possible outcomes you can get for rolling a die. Choosing a name from a phone book. That's all the names in a phone book. Okay, that's the sample space. Now this last one here, counting the number of fish in a lake, that's actually any number. In fact, we should say like any whole number. It's any whole number because you're not gonna, you're counting the number of fish, so it could be any number from 1 to 10,000, 20,000, whatever. So that's any whole number for that one. Okay, so let's look at doing an actual example here where we actually have to find a probability and see if we can't figure that out. So one way to think about probabilities is of all the events in a space occurring is through a probability distribution, and probability distributions are helpful because they help us kind of lay out what the probability of all the stuff happening is. Okay, so in this example, suppose we got 100 marbles in a bag. We got 50 red, 30 blue, 10 yellow, 10 green. So we have 50 total. All right, and we want to look at the probability distribution. Okay, well to do this, we are going to write out basically the probability for red, the probability for blue, probability for yellow, and so you make a table essentially, and so you can see all the probabilities kind of laid out before you there. So we got red, we got blue, we got yellow, and we got green. Okay, so that's those. Now we want, in this row here, we want the probabilities. Okay, so here's our probabilities. Well, for red, it's 50%, so it's 0.5, right? 50 out of 100. For blue, it's 30 total divided by 100. That's 0.3, 0.1, and 0.1. Okay, so this is what a probability distribution is. It allows us to easily and quickly look at the probabilities. Now these ones are easy, right, because it's out of 100, they're whole numbers, they're intervals of 10, but sometimes they're not that nice. And so kind of laying out all the probabilities can be helpful, especially later on when we make when we try and visualize probabilities with density functions. This will be helpful as well. Okay, so that's what the distribution looks like. The few things here that it also wants. Get rid of this. Find sample space probability and probability of drawing a blue or a green marble. Okay, well I said earlier the most important thing is thinking about what is the most important thing is thinking about probability as the number of favorable outcomes divided by the total number of outcomes. All right, so we want to know if we want to draw a blue or a green. So we got to think about how many blue marbles there are. There are 30. So the probability of, we write it like this, probability of blue or green. Okay, that's equal to the number of blues or greens. Boy, my spelling is awesome today. The number of blues or greens divided by the total number of marbles. So the total number of marbles. Okay, so what is that? Okay, well this one's pretty straightforward. Blue, there is 30 of them, and the green, there's 10. So it's going to be 40 total out of 100, which is 0.4. Now, did you have to write all of that out? No, you didn't. But when the problems get more difficult, you want to really be thinking about probability in terms of number of favorable outcomes, the things that you want, the number of ways that can happen, divided by the total number of outcomes. All right. So let's go on to the next one, which is the complement. This is the last vocab word for the lesson. All right. The complement of an event is the set of all outcomes not in an event. Okay. So if we wanted the probability of rolling a 6 on a fair die, okay, that'd be 1 out of 6, right? Most people are cool with that. So we would write it like this. The probability of rolling a 6 is 1/6. The probability of not rolling a 6, that would be the complement. So the probability of not rolling a 6, and we'd write that like that. We put a little bar over the top. That means the probability of not rolling a 6. Well, if there's one way to roll a 6, there must be 5 ways to not roll a 6. So the probability of this happening is 5 over 6. Much more likely to happen than if you roll a 6. Let's look at the probability of not drawing a jack from a standard deck of cards. Well, look, how many jacks are there? So if we look at the probability of drawing a jack, we get 4 out of 52. Okay, cool. Well, we want the probability of not doing that. All right, the probability of not drawing a jack, that's going to be, well, there's 48 cards that are not jacks, 48 ways to draw a not jack. Okay, and so that's your probability. And that simplifies, I think, to 12 out of 13. Okay, that's what complement means. All right, and that's pretty much it for the basics of probability. And that should get you set up with at least doing some basic probability problems.